The arrangement shown below has eight consecutive integers disguised as a to h, not necessarily in the same order. All possible sums of two numbers are calculated in the following manner. Any number chosen is added with the other numbers one by one only if both the numbers added are not in the neighboring cells and the sum is noted. So basically it's trying to say A would be added with C, G, D, H, which are not in neighboring cells. B would be added with, let's say, D and H, because these are the only ones which are not in neighboring cells, and that ways, and the sums are obtained. After that, he says there is some additional information given, which is as follows, and then we have to answer the questions based upon this. So let's try to talk about this now. The first information that we have is the number E has 4 factors while F has 5 factors. If a number has 4 factors, that means either it is cube of a prime, it is like 8 or 27 or something, and it might be a product of two primes as well, like 2 into 3, it might be 2 into 5, it might be 2 into 7, it might be 3 into 5, something like this. A number which has got 5 factors, it must be the fourth power of a prime, so it might be 16 or 81 or something like this. Now the point is we have to write 8 consecutive integers, and in 8 consecutive integers some of the sums obtained are 25 to 37. So can I say definitely 81 is not a possibility or any number above that, rather F must be 16 only. Why? If there are 8 consecutive numbers and one of them is 81, can you ever obtain these sums 25, 28, etc.? Of course, the sums would be very large. So that means F must be 16 only. You do not have any other possibility for F apart from 60. Now, if F is 16, what are the possible cases? The 7 consecutive numbers, they can be 9, 10, 11 up to 15, 16. They can be 10, 11, 12 up to 15, sorry, 16 and 17. They can be 11, 12, 13 up to 17, 18. They can be 12, 13, 14 up to 18 and 19. They can be 13, 14, 15 up to 19 and 20. They can be 14, 15, 16 up to 20 and 21. They can be 15, 16, 17 up to 20, I'm sorry, this was 21, 21 and 22. And lastly, they can be 16, 17, 18 and up to 22, 23. So these are all the possible cases. Why have I made all these possible cases? The reason is the largest, the sums that we are getting are 25 to 37. How can I get a sum of 37? Do I get a sum of 37 in any of these cases? Can you just check that? In the first case, am I getting a sum of 37? The largest possible numbers, they add up to 15 plus 16, that is 31. Not possible. Second largest case, 16 plus 7, 33. Not possible. Third largest case, 17 plus 18, that is equal to 35. Not possible. Fourth largest case, that is 18 plus 19. Yes, there is a possibility of having 37. Of course, 18, 19 would be here as well, here as well, here. So all of these cases can give me a 37. The next question, what all cases can give me a 25? Here I can get a 25 by 12 plus 13, but in all the other cases, the minimum possible sum is more than 25. It is 27, it is 29, it is 31, it is 33. So in no other case, I am able to get a sum of 25. That means there is only one case which can give me a sum of 25 as well as a sum of 37. So by that logic, let me remove all of this now. I definitely know that f is equal to 16 and the numbers are 12, 13, 14, 15, 16, 17, 18 and 19, and f is equal to 60. Also, we know that E has 4 factors, so E must be a product of 2 primes. There is no cube here. The product of 2 primes can be 14 or 15. So E can be any one of them. It can be 2 into 7 or it can be 3 into 5. No other number is a product of 2 primes only. So we know now that E and F are these two numbers possibly. Let's move ahead. Now what next is there? When he says that the sum of B and C is same as F and G, so currently I just know about F. I do not know what is B, I do not know what is C, I do not know what is G. So it will be difficult for us to say that which one is F, G, B or C. I'm just forgetting it currently. The value of each of A, D, E, H are odd, out of which 3 are prime numbers. So A, D, E, H are all odd numbers. 3 of them are prime. If A, D, E, H are all odd numbers, that means E must be an odd number, right? E must be an odd number. So E will become an odd number, and the other 3 odd numbers are A, D and H. So I'm just writing it here. They are A, D and H. A, D and H. So now what about the other numbers that are left? We have 12, 14 and 18. These 12, 14 and 18 are B, C and G, right? The other numbers are B, C and G. Now when the other numbers are B, C and G, next thing that we have is sum of B and C is same as sum of F and G, and F is 16. So this F16 plus one of these 3 numbers is equal to the sum of other 2 numbers. Can I say the only possibility is that F plus G is 30, then B plus C would also be 30. That way I can say B and C are 12 and 18 in any order, but G must be 14. G must be 40. How do I know now that which one is BC, which one is ADH? Let's start talking about them. A few of the different sums noted are these. I am going to the largest sum currently. The largest sum is 37. How is that formed? It is formed by 18 plus 19. 18 plus 19 is 37. So if 18 plus 19 is 37, so if B is 18, let us say B is 18, I can't add A with B, right? I can't add A with B because B and A are neighbors. But I can add D and H both. So there is a possibility 18 is B and 19 is D, or 18 is B and 19 is H. That way both of them are possible. So from there I can't say this. Let's talk about the smallest sum, which is 25. How can I get a sum of 25? 25 is the sum of the smallest 2 numbers, and once again by the same logic, 12 plus 13 can be B plus D, it can be C plus A. Both the possibilities exist here. Is there any other possible sum? Let's talk about the other possible sums now. The other possible sums are next we have 36. How can I make 36? Just have a look at this. 36. How can I make a 36? A 36 can only be formed by 17 plus 19. A 36 can be formed by 17 plus 19 only. Now if 17 plus 19 is 36, now can they both be D and H only? Of course D and H are neighbors. I can't have 17 and 19 as D and H. So one of them must be A. Between 17 and 19, one of them must be A. I repeat, if none of them is A, they would be D and H, but D and H cannot be added. How would I have 36 then? So one of them must be A, that means 13 cannot be A. This means 13 cannot be A. If 13 cannot be A, then how can I have a C over here? Because C cannot be added with D or H because they are neighboring cells. C is neighboring with D and H. So if 12 is C, I cannot have C plus D or C plus H. That is not a possibility. The only possibility is when 12 is B. So therefore, by that logic, I must say 12 is B because B can be added with D. They are not neighboring. B can be added with H. They are not neighboring. And then therefore, if that is B, that means this must be C. If that is B, then this must be C. I hope this is clear. Now C cannot be added with A, right? I cannot have a, D or H. So therefore I cannot have D or H over here in place of 19 because C cannot be added with those numbers. So 19 must be A, so that C plus A can give me 37. And by that logic, I can have a D or an H can be here as well. Is there any other possibility through which we can figure out about D and H? Let's have a look. How can I make 28? 28 can be made by 15 plus 13. But 15 plus 13, 15 is E. E can be added with D and H both. So 28 cannot sort it. How can I make 29? G plus E. Can I add G and E? Yes, G and E can be added. They are, not neighbors. How can I make 32? 32 can be made by E plus D or H. Yes, this can be done. D and H are not neighbors of this. How can I make 33? 33 can be made by 17 plus 16. Can I add F with D and H? Yes, this can be added. That means through any other sum, we can't figure out anything else now. So about D and H, we can't say surely, but about all others, we can surely say what are those numbers equal to. So let's have these questions now. Which letter represents a value double of a prime number? So which of the numbers is double of a prime number? G is double of a prime number. That is 14. So my answer is option C. If D is 4 more than H, what is the sum of E and H? If D is 4 more than H, that means D is 17, H is 13. Sum of E and H. E is 15, H is 13. 15 plus 13 is 28. So 28 is the right answer. What is the maximum possible difference between the sum of the numbers in the first row and sum of the numbers in the second row? Sum of the numbers in the first row is 19 plus 12, that is 31, plus 18 is 49. To have a maximum possible sum, I am taking 17 here. 49 plus 17 is 66. Here I have 15 plus 16, which is 31, plus 14, that is 45. 45 plus 13, which is 58. So the difference is 66 minus 58, that is 8, is the right answer. The numbers disguised as A and F differ by how much? F is 16, A is 19. They differ by 19 minus 16. That is 3. And lastly, how many of the following statements is or are true? Let's talk about this. E is the average of B and C. E is 15. B is 12. Average of B and C. Now C is 18. Is 15 the average of 12 and 18? Yes. 15 is the average of 12 and 18. So therefore, first statement is correct. But he says is or are true. Probably there are more options than this. Then E is the average of F and G. Let's talk about that. E is 15. F is 16. What is G now? It is 14. Is 15 the average of 16 and 14? Yes, it is the average of 16 and 14. Let's talk about third. E is the average of D and H. E is 15. What is D? D is 13 or 17. H is 17 or 13. Whatever they are, the average of 13 and 17 is surely 15. So this is also true. And E is the average of B and G. B is 12, G is 14. Is the average of 12 and 14 15? No. So out of these four statements, 3 of them are correct. So my answer is that 3 of them are correct. So these were the 15 questions.